Welcome to lecture 18, polymorphism. So, in the last lecture, if you recall, we saw this program to multiply two matrices using operator overloading, right. So, if you see, so we have a private member data rows and columns, and then you have use pointer to pointer, right. Then we have the constructor matrix int r int c, right. So, whatever we are passing, it will be assigned to rows and columns, right, and this is the dynamic memory allocation for two dimensional array, and then we have taken the user input, right, that is called the input matrix. So, for the rows and columns, what are the data that you are going to take from the user, and here you have display matrix, all right. So, suppose we are getting, let us say, multiplication of two matrices or addition of two matrices, or even the matrix that you are taken as an input, how you are going to display that, right. So, that we have written from line number 33 to 42, and here you go the operator overloading, right. So, it is like you have a name of the class matrix, and then it looks like a function, right, operator star, and then you have inside you have the reference for the matrix, right, other is the reference for the matrix. It is like if you recall, we wrote a program for complex addition or complex multiplication or even both, right. So, in the object we have taken, and then another one you are passing, right. The one object will invoke, another one will be passed, right. So, that is what happening in the main. In a similar way, here you have, so if you look at line number 45, columns not equal to other dot rows, alright. So, then these things will be done, right. If it is not, right, suppose if you want to do the matrix multiplication, the column should be equal to the other matrix row, right. So, that you are checking the condition, and then here you go the matrix multiplication, alright. So, I runs from 0 to rows and j runs from 0 to columns, and then initially you put data of ij is 0, and then for k is equal to 0, k less than columns. So, we are multiplying the row and column component wise, and then you are doing the addition, correct. So, when we take the input from the user, let us say we are taking two input from the user, two pair of input from the user, that is R1 C1 and R2 C2, row 1 column 1, row 2 column 2, and then so here you have matrix 1 object and matrix 2 object. So, then this matrix 1 object input matrix it is calling, so giving as a input, matrix 2 is invoking input matrix, you are giving matrix 2 as a input, and then if you look line number 95, so this is here the star is acting as a operator overloading. So, usually star we use for multiplication, if there are two numbers, a star b will give you multiplication of two numbers. So, here you are multiplying two matrices and you are putting in that result, okay, the resultant one, the result is a matrix, you can see the class, alright. So, let us see if you are giving 2 by 2, one 2 by 2 matrix as an input, another 2 by 2 as an input. So, column and row, column of the first matrix and row of the second matrix, they are same. So, these are the input, this is one matrix, this is another matrix, right. When we multiply these two, right, at least we can check what is the first one we will get. So, 3 into 5 you will get 15, right, and 4 into 7 is 28. So, the first element you should get 43, right, a 0 0, that result 0 0 you should get 43, right. So, rest you can check. So, when you run the code, we will get the output. So, 15 plus 28, the first element was 43, right. So, this is the resultant matrix after multiplication. So, this works based on the operator overloading. In fact, this program we had seen in the last class itself, I will just we have brushed it, right. So, matrix 1 star matrix 2, meaning is this multiplication we have overloaded, the star operator we have overloaded, right, star operator we have overloaded and we got the result, right. So, here usually star operators for simple multiplication. So, here we have used this for matrix multiplication. So, therefore, this is called the operator overloading. We had seen function overloading, and this is an example of the operator overloading. So, now we use this keyword, right. So, this is the pointer. So, in C++ this plays a vital role, right, and in fact, we can use for the multiple use, right. So, we can use this for multiple use cases, right, and we can call this as a pointer. this is nothing but this keyword when we use this is nothing but a pointer. So, this pointer which is used as an implicit object parameter, right. So, when you are assigning, let us say age, where you are passing age some number, right, salary some number, or string, right, some string value, right. When you are doing this, right, when you are having this object's member function, then when we are calling this, let us say age or string or year, right. So, in that case, so we use this pointer, right. So, which is used as an implicit object parameter when an object's member function is called, right, and refers to the invoking object. So, this may be, let us say, the instances or the member functions, right. So, this dot the member function, or we are going to see this arrow the member function, right. So, those things is possible. So, when we consider 3 different cases, in fact, we have used this, and I told that we will explain about this keyword slightly later, and in this class we are seeing about this keyword. So, now this keyword is useful for resolving variable shadowing, right. So, what do you mean by variable shadowing? So, for example, consider this particular program, alright. So, consider this particular program, you have class employee and then you have a data member called ID, and then you have name of the string, right, name, string name. So, then you have float salary. So, now suppose, right, you are passing, in fact, it is a constructor, parameterized constructor. You have, let us say, ID, name and salary. This is what I mentioned when we talk about the theory of what is this. So, here we are assume that we are assigning ID to ID, name to name and salary to salary, right, and then you have one member function called display, right. So, now let us see what is happening, right. Your class is over here, you have a constructor and here you have the member function. So, now you are creating, let us say, 2 objects, one object E1 under employee, right. So, you are having the constructor, it is calling the constructor, which is the parameterized constructor by passing the ID 18, name Virat and 100,000 is the salary, alright. So, ID, name and salary, right. So, 18 Virat and 100,000 as a salary. And the second object you have E2, which is a object whose class is employee, right. So, here you have the constructor, correct. So, 45 is the ID, Rohit is a name and 50,000 is the salary, right. So, this you are passing. So, that means your line number 22 you are passing 18 Virat and 100,000, right. So, what we expect, ID will be assigned to ID, name will be assigned to name, salary will be assigned to salary, right. So, we have passed 18 Virat and the salary is 100,000, and in line number 24 you have passed 45 Rohit and 50,000, right. So, 45 is nothing but the ID, Rohit is a name and 50,000 is a salary, right. So, now let us display, the E1 is invoking, let us say display, what is the output you will get? So, you expect 18 Virat and 100,000, right, and the line number 26 E2 is invoking display and you expect 45 Rohit and 50,000, right. So, this is what the output we expect, but unfortunately we get the output like this, alright. It is showing some random number, right, garbage value, and string is null, the blank space, and then salary is this for E1, right, when E1 is invoking, but whereas we were expecting 18 Virat and 100,000, and in the second case also some random value, garbage value, string is blank, and then here you have, right, some random value. Okay, how you can resolve this problem? So, this is called resolving variable shadowing. So, variables are becoming, right. So, there is a shadow, alright. So, ID you are assigning to ID, you are expecting, alright, ID will be printed, you are expecting name will be printed, you are expecting salary will be printed, alright. But how to resolve this problem? So, that is why this pointer is playing a role. So, now with the help of this, alright. So, one more operator here you are seeing, arrow operator, right. So, that slightly later I will talk about this arrow operator, and here you look, right, the same program, ID is assigned to this arrow ID, alright. So, because here we have the option for the pointer, the usual pointer concept in C++. So, we are having this arrow operator, alright. So, name is assigned to this arrow name, and similarly salary is assigned to this arrow salary, right. So, you are resolving the problem by writing this arrow, right. I hope it is clear for everyone. This arrow ID, this arrow name, and this arrow salary, right. So, when you do this, now let your E1, right, rest of all same, whatever I explained, the program, all the line number 1 to 28 all are same except line number 10, 11 and 12. So, you are putting this arrow, right. So, what is happening when E1 is invoking display, E2 is invoking display. So, now you can see you are getting the output. So, 18 Virat and 100,000 as output, perfectly right, and 45 Rohit, 50,000 you are getting. So, this pointer variable, right, this is called pointer, which is useful when you are assigning the variable, right, or the member data or whatever the parameters that you are passing, right. So, it is useful when you are using this arrow, right. So, when you are using this and then you have a arrow and then you are having ID equal to ID, okay. So, when I am running the code, I am getting the output like this, right. So, is it clear? Suppose if you do not put this arrow, you will get the garbage value. So, this concept is called the variable shadowing. So, using this concept, I mean to say this arrow concept or this pointer concept, we can resolve this problem. Let us say how you are accessing the members using this, right. So, again one more case, right. So, you have class test, right. So, under this you have one data member or member data test string whose data type is string, and here you have one member function, non-static member function, or let us assume that right now it is a member function. In fact, we talked about static, right, you know static. So, non-static member function, and then here you have, we are passing the test string whose data type is string, and this is a void function. So, now test string is assigned to this arrow test string, like exactly what we have done in the previous program. So, now you have get and print, right, which is a member function, which is a void member function, right, and then you have string str, correct. So, whose data type is string. Now, again line number 18, first time we are seeing this arrow set data of str, right. So, set data is the member function, right. So, set data is the member function. So, here you go, this is a set data member function. So, under set data we are again using this arrow, right. So, now you can see what is happening. So, this arrow set data of str, this you are passing, right, this you are passing, and then we will see how this is working, right, by taking the, because this is nothing but the member function. So, here what you are doing, you have one cout statement, the string is this arrow test string. So, 3 places we are using this arrow, right. So, now when your class is over up to here, now go to the main program you have the test object, correct, whose class is test, capital T, right. Test is a small t is an object and capital T is a class. So, now this test object, right, this test object which is invoking get and print, right. So, when it is invoking get and print, right, when it is invoking get and print, so here you are passing this is a test for member accession, right, this is a test for member accession, this is a test for member accession, and that is a string that I am passing, right. So, when you are passing this string that is used in line number 18, so set data str. So, when you use simply it will be a null. So, here this arrow set data of str. So, here you go set data of test string, right. So, test string is nothing but now this one, this is a test for member accession, correct. So, your this arrow test string is nothing but now this is a test for member accession, correct. So, now you are in line number 19, So, line number 19, the string is, right. What is a string? This is a test for member accession, that means this arrow string is nothing but this, right. So, this is what we are assigning over here, correct, this is what we are assigning over here, whatever the string. So, this is the string I am passing, correct, and then this will be printed because of this, right. So, when I run the code, I will get the output, the string is, right. So, this is the string is printing with a colon, and then this is a test for member accession will be printed, right. So, this is how this keyword. So, the case of member data, right. So, this is the case of member data, correct. So, this is in fact member data, right, or the parameter that you are passing, and one is for how you are calling the function. Set data is a member function in fact, right. In the previous program we had seen how we can call whatever the parameter value that you are passing, right, how to assign, how this arrow is useful, right. So, to print or store those values that you are passing, right. So, in a similar way we can call the member function also. Set data is a member function, and this arrow. So, when you have set data like this, so you will get the output like this. The string is, this is a test for member accession, alright. So, like this we can use this. So, we have seen two different cases, alright, how this can be used for the parameters or the variables, and how this can be accessing the member function as well. So, the next one we are going to see this pointer, right. So, here when you look the class complex, we have two private member data, real and imaginary, right. So, then here you go the constructor complex, right. So, where you have R and I we are going to pass, right, and then that will be assigned to real and imaginary, right. So, that is the constructor, and then here you have one member function called add whose class is complex, right. So, you are passing one complex number, correct. So, you are passing one complex number, right. So, here you have real plus other dot real. So, you are adding. So, main program what happens? So, you one object will invoke this add function and another complex number you are passing, alright. So, whichever is invoking those real and imaginary is this, and since you are passing other complex numbers real and imaginary is this, alright. So, then it is returning the complex number with the real and imaginary, and here you have the display member function. So, that will print, it is of the form a plus ib, right. So, which will be printed 2 plus 3i, right, 4 plus 5i, something like that, right. So, that will be displayed over here. So, now you have user real and user imaginary double value, real, I mean these two are variable names, right. So, you are taking the input from the user and you are creating one object, user complex is an object, right. So, you are creating one complex number. So, you have taken the input from the user, for example, I am taking let us say 2, 3, right, if at all I take, right, user real is 2, user imaginary is 3, right. So, here you have the complex which is the class and user complex is the object, right. Another one is the constructor complex. So, the constructor complex you have 3.5 real, 2.0 imaginary, right, and complex is the class, alright. That means the constructor complex, so which is another object, another complex number, right. So, one you are taking the user, right, one input you are taking from the user, another you are passing, right, using the constructor. So, when I am passing this, so let us say 3.5 and 2.0. So, in fact, here also whatever the input that I am taking from the user I am passing. So, that means this constructor will be called, R will be assigned to real and I will be assigned to imaginary, right. Similarly, here it is happening 3.5, 2.0, the real and respective imaginary will be assigned for the complex number, this particular complex number, right. That means this object constructor complex. So, now you have the result complex number or the result object whose class is complex and user complex, right. This user complex, here you go, this is a user complex, this is invoking add function by passing constructor complex, So, assume that this is 2 3 I set, assume that. So, that means 2 plus 3 I we are passing, right. In fact, this user complex contains, right, and this is invoking, and the constructor complex we are passing 3.5 plus 2.0 I we are passing. So, it is equivalent to that, right, for the understanding. So, that means user complex is invoking the add function and then you are passing this 3.5 plus 2.0 I, alright, in the constructor complex. This is what exactly happening, right. So, now see out users complex number. So, user complex number dot display, alright. So, display what is happening, the first number whatever you are taking from the user, so that will be printed. Similarly, constructor complex will invoke display, right. So, then whatever you have passed 3.5 plus 2.0 will be printed, right. So, see out result dot display. So, this in fact we had seen, right. So, when you have 5 and 2 from the user input, the first complex number will be 5 plus 2i, right, that is nothing but the user complex number, and second one is a constructor 3.5 plus 2.5. The addition of these two is 8.5 plus 4i. So, now the question is where exactly we are using this, right. So, here you go. So, when you want to access the object, so as I said, one of the object which is invoking the function where in the other object you are passing, right. So, suppose, so here in this case if I want to display, right, the resultant of the complex number, we simply put return complex, some real, some imaginary, right. So, we are returning this, or you can have some complex result, right, store it in the result. So, that will also be displayed. Suppose I want to display other dot real and other dot imaginary, what I can do, simply return other, right. Now, the question is, suppose I want to display this, that is right, this real and this imaginary, right. Suppose I want to display this real and this imaginary, what I can do? So, I can use this pointer like this, return star this, right. So, when I use this return star this, so this is the pointer, in fact we are using the dereference operator, alright. So, addition is not correct here. So, here how I am going to display the object that is invoking the function where you are passing certain values through the object, alright. So, now the object that is invoking, so I want to display right inside the member function. So, for this return star this is useful. So, that means I can access the object with the help of this, right. I can access the object with the help of star this. So, now you see 5 comma 8 I am giving as a input, right, 5 comma 8 I am giving as a input, and you can see that the first complex number is 5 plus 8i and the constructor complex number is 3.5 plus 2i. In fact, the addition of these two we have done that, right. So, our case is this is not a sum of complex number, you forget about this, alright. So, in fact, this should be the first complex number, I just put that return star this, I have not disturbed the program, right. So, the addition point of view this is not right, but the concept point of view return star this, how I can access this object. So, I can access this object with the help of this, right. So, when I put this you can see that the object that is invoking, right. So, here you go the main program, right, user complex that is invoking add, line number 44, user complex that is invoking the function add. So, when it is invoking the function add and then you are passing this. Now, my question is how to display this user complex inside that member function. So, for accessing this object I need star this pointer, return star this. So, when I do this 5 comma 8 I am passing, in fact that particular object is invoking the add function and then you are passing this constructor complex number, right. So, you are getting, right, you are getting by putting return star this, right, by putting return star this, so that will be printing the first complex. So, constructor complex number if I ask you to print, I mean which is nothing, right. So, what will you do? You simply put return other. So, when I put return other, we know that I will get 3.5 plus 2i. But how do you access that particular object which is invoking the function, right? So, for this you use return star this, and return star this will return the first complex number, right. So, this is how this keyword, right. So, this keyword you can assign whatever the parameters that you are passing, right. In fact, in the case of a constructor, when we saw the first example, right, that Virat and Rohit example. So, how you are assigning in the data or the variable, all right. Even some of the programs previously we had seen how you can assign with the help of this. In fact, this dot we had seen, if you recall, we had seen this dot. And the second program we have access the member data, right, access the member function, right, access the member function, set data, this arrow set data, if you recall, right. And then whatever the string that you are passing, the set data with the help of again this arrow operator, we would able to handle. And here in this case, the addition of two complex numbers. So, we are passing one complex number with the help of a constructor, another one is invoking the member function, right. So, one object is invoking the member function add, and you are passing this constructor complex number. So, in that case, right, I want to print the object that is invoking the member function. So, for accessing the objects, we have used return star this, all right. So, in today's class we have seen operator overloading and this keyword, right. So, this keyword, so three different cases, the member data or simply a data, member function, and then how you can access the objects, right. So, with this I am concluding, and in the next class we will talk about method overloading. Thank you.